Hi, so this is showing how the Boltzmann distribution works. So the Boltzmann equation allows you to turn a difference in energy, a delta E, into a mole ratio. So the Boltzmann equation is N1 on N2 equals e to the power of negative delta E over KT. So that's where N1 on N2 is the mole ratio, and delta E is the energy difference. So the difference in energy between state 1 and state 2, and KT is the gas constant times the temperature, which if it's at room temperature, that'll be that works out to be 2.48 kilojoules per mole. Okay, so then we just substitute in here. So it's E, the delta E. So the energy difference, I'll just take that energy difference from the table you sent in the email. So the energy difference between conformer 1 and conformer 2 was 0.8 kilojoules per mole, with the negative symbols from there, and then divided by KT is equal to 2.48 kilojoules per mole. That works out to be e to the negative, you do it in your calculator, e to the negative 0.3226, which pump that into your calculator, comes out to be 0.724. So what that means is the mole ratio of N1, N2 is equal to 0.724. So that means for every 1 mole of molecules that are in conformation N1, there are 0.724 moles of molecules in conformation N2. So that makes sense. So there's a small gap in energy between N1 and N2, where N1 is slightly preferred, N2 is a little bit higher in energy. So that makes sense that there'll be slightly more molecules in state 1 than in state 2. So for every 1 mole of molecules in state 1, there's 0.72 moles of molecules in N2. And you can keep on applying the Boltzmann equation to compare any two energy levels. Right. Hope that helps.